Welcome to this training session on Azure Storage. Today, our main focus will be on how to create, configure, and manage a file share in Azure Files. Let's get started. Let's begin by defining what Azure Files is. Azure Files is a platform as a service, or PaaS, offering that provides fully managed file shares in the cloud. At a basic level, it allows you to access your files using industry-standard protocols, specifically Server Message Block, or SMB, Network File System, or NFS, and HTTP. Because it uses these standard protocols, clients can easily connect to Azure file shares from Windows, Linux, and macOS devices from anywhere in the world, provided they have internet connectivity. For a deep dive, it is critical to understand that this is a truly serverless deployment. Unlike an on-premises file server, you do not need to patch an operating system, manage a virtual machine, or worry about underlying hardware. Azure handles all the infrastructure management for you, providing a highly scalable and reliable file system natively in the cloud. Take a look at the flowchart on your screen. At the top, we have our client devices, which include Windows, Linux, and macOS platforms. These devices communicate downwards through the standard protocols node, utilizing SMB, NFS, or HTTP. This traffic flows directly into the Azure Files service. The most important part of this diagram is the bottom node, serverless, fully managed infrastructure. This highlights that there are no intermediate servers or virtual machines that you must manage between your clients and your data. Azure Files provides a seamless, direct connection to your cloud-based file shares. Why should you choose Azure Files over other storage solutions? The most common reason is the lift and shift scenario. Many legacy on-premises applications expect to interact with a traditional file share. By using Azure Files, you can migrate these applications to the cloud with minimal to no code changes, as they can simply mount the Azure file share to the same drive letter they used on-premises. Furthermore, Azure Files excels at shared access. Multiple virtual machines can mount the same file share simultaneously, providing centralized read and write access. This makes it an excellent choice for storing shared application configuration files, development tools, diagnostic logs, and crash dumps. As a deep dive comparison, remember that files in an Azure file share are true directory objects organized in a hierarchical folder structure, exactly like an on-premises file server. This is different from Azure Blob Storage, which relies on a flat namespace and container architecture. This diagram illustrates the primary use cases for Azure Files. On the left, we see an on-premises application performing a lift and shift migration directly into the Azure Files share. Below that, we have multiple Azure virtual machines, VM1 and VM2, concurrently mounting the same share for simultaneous read and write access. Finally, the arrow points to the hierarchical folder structure, emphasizing that the data is stored in true directories and folders, preserving the traditional file system layout that your applications and users expect. Before creating a file share, you must understand the available performance tiers to optimize costs and latency. Azure Files supports two primary storage tiers, Premium and Standard. The Premium tier is backed by high-performance solid-state drives, or SSDs, providing consistent low latency. It uses a provisioned billing model, meaning you pay for the capacity you reserve, and is ideal for high-performance workloads. The Standard tier is backed by magnetic hard disk drives, or HDDs, and uses a pay-as-you-go billing model. Standard offers three specific access subtiers based on usage: transaction optimized for heavy traffic, hot for general-purpose team shares, and cool for cost-efficient archival. For a deep dive, you must know that you cannot mix these in the same storage account. Premium file shares must be created in a specialized file storage account type, whereas all standard file shares are created in a general-purpose V2 storage account. Here we have a breakdown of the Azure Files storage tiers. From the top, the path splits into Premium and Standard. Follow the Premium path on the left. It highlights SSD backing, provision billing, and the requirement of a dedicated file storage account type. Now follow the Standard path on the right. It utilizes HDD backing, pay-as-you-go billing, and general-purpose V2 accounts. Notice how the Standard tier further branches out into three distinct access patterns: transaction optimized, hot, and cool. Choosing the right path on this diagram is crucial for meeting your application's performance needs while strictly managing cloud costs. Now let's walk through the actual creation process. How do you create a file share? First, navigate to your Azure Storage account in the portal. Under the Data Storage section, select File Shares and then click the plus File Share button. At a basic level, the creation blade requires you to provide two things: a unique name for the share, and a defined quota limit. The quota sets the maximum capacity that the share can consume. By default, a standard file share has a maximum capacity limit of 5 TB. However, for our deep dive, you should know that you can vastly expand this limit. By enabling the large file shares feature at the storage account level, you can create file shares that scale up to a massive 100 TB per share. Note that if you selected the premium SKU, your shares support 100 TB by default. This sequence diagram maps out the exact steps an administrator takes to provision a file share. The admin starts by navigating to the target storage account within the Azure portal. The portal displays the menu, and the admin selects File Shares followed by the plus File Share Creation button. Next, the admin inputs the required name and quota parameters. The portal then sends these instructions to the backend storage account service, which provisions the actual file share infrastructure. Finally, a success message is returned to the admin, indicating the share is ready for use. Once your file share is created, you must secure it. Azure Files supports several authentication methods. The most secure and recommended method is identity-based authentication over SMB. This allows you to integrate the file share with your on-premises Active Directory domain services, Microsoft Entra domain services, or Entra Kerberos. You can then use Azure Role-Based Access Control, or RBC, to grant granular permissions to specific users and groups. The second method uses storage account access keys. Every storage account has 2 access keys. Using an access key provides full, unrestricted control over the file share and bypasses all RBAC restrictions, so they should be heavily guarded. For a deep dive, you might consider using Shared Access Signature, or SAS, tokens for granular control. However, a critical constraint for Azure Files is that SAS tokens are only used to provide REST API access from code. You cannot use a SAS token to mount an SMB file share on a virtual machine. This flowchart breaks down the 3 authentication paths for an Azure file share. The left path shows identity-based authentication, which connects to your directory services like ADDS or Entra ID and securely applies Azure RBC roles for access control. The middle path represents storage account access keys. Notice that this path provides full control and completely bypasses RBC, representing a higher security risk if shared improperly. The right path covers SAS tokens. The distinct limitation highlighted here is that SAS tokens are restricted to REST API access only and cannot be used for traditional SMB mounting. How do your end users and servers actually connect to the file share? Azure provides straightforward scripts right in the portal. For Windows environments, you can map a network drive through File Explorer or use the command line netuse utility. For Linux virtual machines, you use the mount command with the CIFS type. At a basic level, if you are mounting the share using access keys instead of Active Directory, your username must be formatted as Azure/ followed by the storage account name, and the password is the long storage account access key. For a technical deep dive, there are 2 common gotchas. First, the SMB protocol requires port 445 to be open for outbound communication. If your ISP blocks this, the mount will fail. Second, to ensure a Windows server automatically reconnects to the file share after a reboot, you must use the key utility to persist the credentials in the Windows Credential Manager. This diagram visualizes the mounting process across operating systems. At the top, a Windows server connects using the netuse command over port 445. Below it, a Linux server connects using the mount tcifs command. Both converge on the Azure file share. The crucial part is the credentials node on the left, which feeds into both servers. When utilizing storage keys, the format is strict. The username must be Azure/account name, and the password is the storage access key. Once your data is in the cloud, you must protect it. Azure Files provides a native snapshot capability. What are snapshots? They are read-only, point-in-time copies of your file share. The basics of snapshots is that they are highly efficient and incremental. This means that a new snapshot only captures and charges you for the data that has changed since the previous snapshot, saving you significantly on storage costs. Why do we use them? Snapshots allow you to instantly roll back a share or recover specific files if data is corrupted by an application bug or accidentally deleted by a user. Diving deeper into the architecture, Azure supports creating up to 200 snapshots per individual file share. You must also remember that snapshots are permanently tied to the base file share. If an administrator accidentally deletes the actual file share, all 200 snapshots are instantly deleted alongside it. This sequence diagram demonstrates the efficiency of file share snapshots. At 10 a.m., we take snapshot 1, which captures the baseline data of the Azure file share. At 12 p.m., we take snapshot 2. Notice that snapshot 2 only captures the incremental changes that occurred over the last 2 hours, rather than duplicating the entire dataset. Finally, if a user makes a mistake, an administrator can reach into snapshot 2 and restore the specific corrupted file back to the live file share, recovering the data instantly. To combat the risk of an entire file share being deleted, you must configure soft delete. Soft delete is enabled at the storage account level. When enabled, if a file share is deleted, it isn't permanently erased. Instead, it transitions to a soft deleted state. You can configure this retention period to hold the deleted share for up to 365 days, giving you ample time to recover from malicious or accidental deletions. Finally, let's look at a powerful hybrid feature, Azure File Sync. Why use it? Azure File Sync allows you to cache your Azure file shares locally on an on-premises Windows server. This provides your local users with the fast, local network performance they expect, while centralizing the data in Azure. As a deep dive, Azure File Sync utilizes a feature called cloud tiering. Cloud tiering intelligently stores only recently accessed hot data on the local server's physical hard drives, while seamlessly moving older, cold data into the Azure cloud. Our final diagram illustrates a robust hybrid architecture. An on-premises Windows server runs the Azure File Sync agent. The agent intelligently splits data using cloud tiering. Frequently accessed hot data is kept on the local server drives for maximum performance. Meanwhile, the bulk of the data synchronizes up to the Azure file share in the cloud. To protect the cloud data, soft delete is enabled. If the active share is deleted, the flow moves to the retained node, where the data is safely held for up to 365 days before permanent deletion, ensuring ultimate data protection.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB730 exam, if you open it, so you can see here this and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.